Hello everyone, I am Abhishek and today our topic is differentiation. And now the question is, what is called differentiation? So let us suppose that y equals to fx be the graph of a function, and at x equals to c the value of the function is fc. Therefore, the coordinate of this point will be c comma fc. Now let us suppose there is a small increment in x. Then the point c comma 0 will shift to this point whose coordinate is c plus delta c comma 0. Now the functional value at that point, that is c plus delta c, will be f of c plus delta c. So therefore the coordinate of this point will become c plus delta c comma f of c plus delta c. Now we can note that for the small change in x, there is a small change in the functional value of fx, and that change is f of c plus delta c minus fc. Hence, the differentiation of the function f at x equals to c means the small change in f or y divided by the small change in x when the change in x is infinitesimally small. So geometrically, f dash c means the slope of the tangent of the function y equals to fx at the point c comma fc. Therefore, if the angle of inclination of the tangent be theta, then we can write f dash c is equals to tan theta. Now let us see some derivatives of some standard functions. Number 1, differentiation of x to the power n with respect to x is n into x to the power n minus 1, where n can be any real number, not necessarily integer, it can be any real number. Second is ddx of e to the power x is e to the power x. Third one is ddx of a to the power x is a to the power x into ln a or log a to the base e. The fourth one is differentiation of log x to the base e with respect to x is 1 by x. The fifth one is ddx of log x to the base a is equals to 1 by x log a. Here log is always of base e. The sixth formula, ddx of sin x is equals to cos x. Then ddx of cos x will be equals to minus sin x. Then ddx of tan x will be equals to secant square x. Then the ninth formula, ddx of cot x will be equals to minus cosecant square x. Then ddx of secant x equals to secant x into tan x. Then ddx of cosecant x will be equals to minus cosecant x into cot x. Then ddx of sin inverse x will be equals to 1 by root over of 1 minus x square. Here the value of x should be lying between minus 1 to 1, including minus 1 and 1. Next, ddx of cos inverse x will be minus of root over of 1 by root over of 1 minus x square. Then ddx of tan inverse x will be equals to 1 by 1 plus x square, where x can be any real number. Then ddx of cot inverse x will be equals to minus of 1 by 1 plus x square. Now ddx of secant inverse x will be equals to 1 by mod x into root over of x square minus 1, and ddx of cosec inverse x will be equals to minus of 1 by mod x into root over of x square minus 1. Here mod x should be greater than 1. Now there are some fundamental rules of differentiation. Now the fundamental rules of differentiation are: differentiation of a constant with respect to any variable is equals to 0. ddx of c into fx equals to c into ddx of fx. Next, ddx of fx plus or minus gx will be equals to ddx of fx plus or minus ddx of gx. Here f dash x means ddx of fx. Now the fourth one is ddx of fx into gx, which is also known as the product formula, is equals to f dash x into gx plus fx into g dash x. The fifth one is ddx of fx by gx equals to f dash x into gx minus fx into g dash x divided by square of gx. Now let's see the chain rule or the differentiation of function. Here f of g of x is called the function or the composite function. Hence, the ddx of f of g of x is equals to f dash gx into differentiation of gx, or we can write f dash gx into g dash x. Now for example, let us find out the derivative of sine x square at x equals to root pi by 2. Here we can see that on x, square function is operating and it is making x as x square. Then the sine function is operating on x square, it is making the x as sine of x square. And again another sine function is operating and it is making it sine of sine x square. Therefore, if we assume that fx equals to sine x and gx equals to x square, then we can write that the given function is of the form of f of gx. Here gx is the square function making x square, then f is a sine function making sine of x square, and then another f making it sine of sine x square. Now if we differentiate this function, this composite function, then it will give f dash of f of g of x, f dash gx into g dash x. Now we know that f dash x equals to cos x. So therefore f dash of sine x square will be cos of sine x square. Therefore f dash of f of g of x will be cos of sine x square. Now into f dash of gx. So therefore we need to differentiate sine gx. So it will give cos of x square as gx equals to x square. Now into g dash x will give 2x. So ddx of sine x square will become cos of sine x square into cos of x square into 2x. Therefore ddx of sine x square at x equals to root pi by 2 will become cos of sine root pi by 2 whole square into cos of root pi by 2 whole square into 2 into root pi by 2. That is, we have to put root over of pi by 2 in place of x. Now which will become cos of sine pi by 2 into cos pi by 2 into 2 into root pi by 2. Since cos pi by 2 equals to 0, the answer is 0.